Hello guys, in previous video we have seen how can we take the input of the linked list. Now in this video we are seeing the problem insert the element in particular position. We have given a linked list. Basically we have given a linked list. This is our linked list. We have given a linked list and at a certain position we want to insert the element. They also give an element, they also give the position, and we want to insert at a certain position. See, here they given at second position we want to insert the 100. At second position we want to insert the 100. See, in the second position we having the 100. How can we go this problem? If you guys understand the previous question, previous input, how can we take the input of the linked list? Then you may get some idea, but no problem. This question is very important. How can we do this problem? How can we solve this problem? What is the main intuition I want to get? I want to insert my linked list is 1, 2, 3, 4, 5, 6. 1, 2, 4, 6, right? Yeah. My intuition is I want to insert at this second position. In the second position I want to insert 100. Okay, 100 is a new note, right? So what is my intuition? If my pointer will be, if I take my pointer to at first position, because I want to insert at a second position. If I take my pointer to at the first position, then if I attach this 2 to 100, then my 2 will be so my 100 will be at the second position. Of course, if you got this thought, yes, you are going in a right direction. Actually that is the right direction, but you miss some logics. Okay, you want to insert at the second position. That means you came to the tail at the first position. The tail is at the first position. Now you want to insert 1 to 2 at the first position to second. So you want to insert at the 2 to 100. Attach the 2 to 100. First come the tail to a first position, then attach 2 to 100. If you are thinking this approach, yes, you are going right, but not exactly right. So what is my approach here? At second position I want to insert the at second position I want to insert the 100. So if my pointer will come to at the first position, and the indexing will be 0. By the way, indexing will start from the 0. Here we are taking indexing as imagining indexing as a 0. Now I want to come up to, if I come to first position, then I can, if I attach this 2 to 100, then of course 100 will be at the second position. You may think that yeah, my answer is over, but still my answer is not over. And also you should also attach 100 with 3 also, then only everything will go over. 1, 2, 100, 3, 4, 5, 6. My linked list became, see, my new linked list came. Now my new linked list came 1, 2, 3, 100, 3, 4, 6. Your approach is right. Your approach is absolutely right. You are attaching tail to 100. Next 100 to 3. but 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 let me see. Your approach is right, but you missed something. I will tell what we actually missed. We attach a 200, right? We attach 200, but afterwards, how can we attach 100 to 3? Because after attaching 2 to 100, then my link will be breaked now. Now my new linked list will be 1 to 100. That's it. If I want to attach 100 to 3, my 3 address is not there. The address of the 3 will be not there. If I know the address of the 3, then we can go further. That's not a problem. I want to attach 1 to 3, but I cannot directly attach the 100 to 3 because I don't have the 3 address of the 3. I don't know the address of the 3. Where is the 3 address? Where is the 3 node address? I don't know where to attach 100. I don't know where to attach 100 because I attached this tail. Sorry, this is tail. This is n. Attach T to n. Now n to which node I can attach? To which node I can attach? I don't know where to attach. I want to attach 100 to 3. This is my target. Then we can get the answer. But there is no 3 address. 3 address is missing. The link is breaked. I don't know the address. The link is breaked. I don't know the address. See here. See this 1 to 100 is there. But 3 address is not there. I want to attach 3 to 100 to 3. But 3 address is not there. The node 3 address is not there. This is missing now. Because 1 to 100. This is missing because I attached, right? No, it is missing. How can I do? Simple actually. This is actually simple. Okay. Before attaching, what we will do is we will keep a temp variable, a temp node. This is a temporary address. For temporary address, because my address should not miss, right? So I will store, before attaching, I will store this 3 address, means this is tail. I will store this in temporary. I store tail.next address, means I want this address. I don't want to miss this address. I want to store somewhere to this address. If I store this address somewhere, then that will be no problem. So I am storing in temporary address. I am storing tail.next. Tail.next. Acha. Now, so I stored tail.next. Here in this case, what is the tail.next address? Temp will be, what is here in this link list, the temp address tail.next. Tail means T here. Okay, I kept tail. This is tail. Okay. This is n. Okay. This is n. Okay. Now I stored this tail at the rate of 3 in temporary variable. At the rate of 3 means the address of 3. Now we want to attach tail to next node, new node. Tail.next is equal to n. So okay, no problem. Tail.next is equal to n. We attach tail.next is equal to 100 node. And next we want to attach. After attaching this, what happens? This link will be breaked. After attaching, this link will be breaked. So this link will be breaked, but we want to attach this 100 to 3. But we stored, but before we seen like there is no, we haven't stored the address of the 3 in before case. But in this case, we have stored the address of 3 in temporary variable. That means tail.next. So to temp will attach. This is temp. Okay, this is temp. So n dot next will be temp. In temp. No address is not missing for me. We stored the temporary address in temp variable. So no problem for us. The problem is over. So the thing is, we should store this address. Storing this address is the most important thing. We want first tail to n, next n to temp. Over. See, the linked list become 1, 2, 100, 3, 4, 6. Acha. So what if I say I want to insert? Okay, this is over. You came to know what I am giving another condition. I am giving another condition 3. I am giving another condition to insert 101 at the position 0. I want to insert at the position 0. This is the 0th position. How can I insert? First, create a new node. This is the base condition. Create a new node 101 n, and this is the head. This will be the head, right? Now attach n to head. Now change the head to n. Simple. Okay, let's understand in the code form. Let's write the code. I will love this. Yeah. Now I am creating a function, and the function that is public static, not static node insert at position. I am taking the function insert at certain position, so insert at position, then parameter should be node head int position int element. This will be my parameters. Okay, now currently first target is our first target is if I want to insert at the second position, I want come this tail to this first position. This is the most important. I want to come first. The main target is first I want to bring this tail to this first position. This is first our main target. Let's code this first of all. I want to bring this, means if this is the position I want to insert at certain position. I want to if I want to insert at this element in certain position, I want to bring this tail to position -1. Position -1. Position -1. Okay. So first let's do this duty. Okay. First, initially I am keeping a tail is equal to head, and here initially it is 0 1 0 1. Initially if I Observe this. I am applying now the for loop. For int I is equal to 0. So first our target is to keep come to a tail, right? So initially I is equal to 0. I must be less than position minus 1 here. What we are doing initially if I is tail is equal to head initially at I is equal to 0. At I is equal to 0, tail is head. Tail is at head, means at position 0. Tail is at head. At I is equal to 1, tail is at head. Initially at tail is at head. And what happens? Tail is at head initially. Now at I is equal to 0 loop, tail will become tail dot next. Tail dot next. Tail will become tail dot next. If I is equal to 1, at I is equal to 1, tail at I is equal to 1, tail came to at first position. That means we want to make I must be less than position minus 1. Just once try run this, okay? Tail is equal to tail dot next. For position minus 1 times, make tail is equal to tail dot next, less than position minus 1 times, not equal to position minus 1 times. Now afterwards the tail came to at this first position. I will write again. Two, 3, 4. Now the tail came to at first position. This is completed. This is completed. This is completed. Now afterwards we want to attach the node. Before attaching the node, what I told, before attaching this node, store these 3 in temporary variable. Means store temp is called, store the temporary address tail dot next in temporary address node temp is equal to tail dot next. Now attach tail. Before attaching, create a new node n is equal to new node element. Now attach tail dot next is equal to n. Now n dot next is equal to temp. Completed. Now return head. I should return head. Right, I should return head. Now we also forgot it. What if position is equal to 0? Right. If position is equal to 0, what should you do? First, n dot next is equal to head. Next, head is equal to head dot next. Return head. This is the answer. I already told how it is happening in pictorial form. Now let's run this code. Let's take the input and run this code. 1 minute. Now in main method, let me print in a straight line, okay, with some gap. This will be fine. System.out.println before inserting. This is for This is for the before inserting and printing and after inserting. System dot out dot println after inserting. Now I am calling the function take input ll, not take input ll, sorry, insert at position, head, I am taking head, position will be 2, I am inserting 100 in the position 2. Now let's run it. Let's take one input. I am taking input now. 1 2 2 3 4 5 6 7 8 minus 1 minus. Sorry, I forgot to print after inserting. Let's print after inserting also. Okay, let's run again. 1 2 3 4 5 6 7 8 9 minus 1. Now see the difference. Before inserting, this is 1 2 3 4 5 6. This is after inserting. This is before inserting and this is after insert. Thank you for watching my video. Thank you. And I forgot it. In next video, I will give just a hint for the deletion of the linked list. I just give the hint for the deletion of the linked list you should do. In this series, I will not do every code. I will do one code and I will give hint that you should code that. It will improve our coding skills. Thank you for watching my video.